Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over a bunch of exercises for more practice with destructuring in JavaScript together. In the previous video, we went over the main concepts for destructuring, specifically array destructuring as well as object destructuring. So there's going to be a bit more practice with some of those concepts as well as some more tricky parts of destructuring in JavaScript with things like functions as well as for up loops. Let's get right into them. So the warm-up exercise here, I'm going to kind of, as all the other videos, have a bunch of comments at the top of each of these. I'm going to go through them together and kind of enunciate what I think each one of these should do, give you a few hints if possible, and then I'll let you try it out yourself, and then we'll go through a possible solution together. So for the warm-up, just to get our fingers warmed up here, this is the exercise that we got to go through. So for the first one, we want to create a variable called jungle that points at this array right here. So this is an array of strings, right? We have 1, 2, 3, 4, 5 strings: monkey, lion, panda, rabbit, and squirrel, right? We want to use the array destructuring syntax to destructure out lion and rabbit from this array while ignoring the other animals. So lion is in index 1 and rabbit is in index 3. Okay, then we want to print out the lion and rabbit variables just to make sure that we actually got them out of there and we didn't get something like undefined or one of the other values by accident. All right, so give that a shot and then we'll go through a solution together. Okay, so I'm going to first kind of just make this on two separate lines just so it's a bit more clear what's happening. So I'll just say jungle is equal to this. Technically, we could do this all in one line, but we'd lose the variable jungle. Maybe I'll show you that really quick after this example. So what we want to do here is we want to use the array destructuring on the left-hand side. And on the right-hand side, we want to put the thing that we're destructuring out of, right? Now, inside of this array destructuring, we can choose variable names for kind of with an array, at least on the right, the positional things that we want to pull out of the array on the right hand side. So we want to ignore monkey, we want to keep lion, ignore panda, keep rabbit, and then ignore squirrel. So to ignore something, we saw that we can just kind of use comma and we just don't give it a name. Then I'm going to say we want lion. Then we want to kind of ignore panda. So we're just going to give another comma. That's going to be another space kind of. You can think of it just as a space is an ignore, right? And probably might be more clear if I put a space here just so it makes a bit more sense. And then here we want rabbit. And then technically we don't even have to go further. Everything after that just gets ignored by default if we want. Now I could have named these whatever I wanted, right? But just so it's super clear what these actually are, I'm going to actually use the names of the things that I'm trying to pull out. So if I console.log out lion as well as rabbit, hopefully we actually get these logged out, and let's see what we get. So if I first make sure I'm in the right directory, then I'm going to run node, and this is going to be the warm-up exercise. And look at that. All right, so we get lion and rabbit. Okay, perfect. So hopefully that kind of makes sense. It's a good warm-up. Now, what I mentioned earlier, just before we go to the first exercise, if you did really want to ignore creating a separate variable for this, what you could kind of do is something that looks like this. So I could do this on the left, like that, and then I could kind of do this all in one go. And it would look just like this. Okay, so if we just had the array directly, we wouldn't need to intermediary variable of jungle. We could just destructure out of it right away. Okay, and this might get cut off a little bit here with the squirrel, but if I run this one more time, you'll see that we indeed get lion and rabbit. All right, hopefully that makes sense. Let's go to exercise 1 together. Okay, so things are going to start getting a bit more complicated with some of these examples because we can really do quite a lot of fun things with destructuring. So the first thing we want to do here is create a variable called snacks. Okay, and snacks is going to point to this object right here. So it's the three properties: chips, which is going to point to this object right here with its own properties of name and salty; candy, which is the same thing; and then chocolate, which also has the same properties, just different values. Okay. Then what we want to do is we want to destructure out candy from the snacks using the object destructuring syntax. We also want to destructure out fruit from our snacks object. Now you might be thinking, well, Nader, there's obviously no fruits in here. Well, that's kind of the point. So what I want you to do with fruit though is set it to a default value if it doesn't exist in Snacks. So we know it doesn't exist in Snacks, but let's just pretend that this might be a massive object. We want to like hundreds and hundreds of snacks, for example. And just in case it doesn't exist, we want to give it a default value of banana and salty of false. Okay. Yeah, I don't really know if banana, I guess it does count as a snack. Definitely not salty, at least not the bananas I've eaten, so hopefully that makes sense. So if it doesn't exist, we want it to give it a default value of this object named banana, salty or false for the fruit. Okay, and this is all within the same object destructuring syntax. So we shouldn't be doing kind of multiple lines for this or like assigning fruits to this object. We're just destructuring out of this object and trying to pull out two keys, candy and fruit. And if fruit doesn't exist, we're going to assign a default value. Okay, so if you're not sure how that default value works with destructuring, you might want to kind of either look at MDN documentation for that or take a look at the previous video where we went over that in detail. Then I want you to print out the variables pointing to candy and fruit and make sure they actually have the correct things inside of them, specifically candy being this object right here, Twizzlers with salty of false, and then fruit being banana with salty of false. Okay, so give that a shot yourself and then we'll go through it together. All right, so to start, we're going to say const snacks, and I'm going to just copy this so you don't have to watch me kind of sit here and type it out. Then the interesting part here, right? Destructuring candy out of this. So with the object destructuring, we use, instead of square brackets on the left-hand side, we use the curly brackets, right? Because this is an object instead of an array. And on the right-hand side is going to be our snacks. Okay, so inside of here, we don't put kind of positional things that we want. We actually put the names of the keys. So we want candy, right? And that's going to hopefully pull out this object right here, the value for the candy key that we've destructured out of snacks. We also want to pull out what we said was fruit, right? But we know that fruit doesn't exist in here, but maybe again, like I said before, this might be a gigantic object. So to set a default value for anything, we could do this for candy too. It just wouldn't take effect because candy does exist. But for fruit, we want to have a default value of name of banana and salty of false. So I'll just copy that, just save some typing for myself. Okay, so this is kind of what we want to end up with. Now I just want to show you that this works first and kind of go through the syntax a little bit. So if I log out both candy and fruit, I expect to see candy with Twizzlers of salty of false, and then fruit with the default value with name of banana, salty of false, instead of undefined, which it normally would be if we didn't give it a default value. So I'm going to run node, and this is going to be exercise 1. And look at that, right? We get both our Twizzlers, salty of false, and then name banana, salty of false as well. So they're both being printed out correctly, and we're destructuring them out correctly as well. So just want to note here, right? This syntax can get quite hairy pretty quickly, right? We here have object destructuring going on, but then inside of that object destructuring, we're also doing a default value, which itself is also an object, right? So I hope you can see that, you know, in some cases, especially when you start to get with like more complicated destructuring or even nested destructuring, or, you know, nested maybe destructuring with something like default values, at some point it really does become kind of unwieldy and maybe even unreadable, and probably better off just not even using it at all and just kind of going with a much simpler syntax of pulling things out inside of the body of the function. But in this case, I think it would be okay. I probably would go this far. Any further than this, or like too many more assignments or lines in this, and I probably would try to think twice about whether to use destructuring in that context. Okay, hopefully that one makes sense. Let's go to exercise 2. So for this one, we want to create a variable called store, and store is going to be a map object. Okay, so if you're not sure with what maps are, very similar to objects, I have a video on that on the channel as well. Very kind of similar in the key value pair context to objects, but there's some fundamental differences as well. So I want to specifically use a map because this example actually will not work with vanilla objects in JavaScript. So definitely use a map for this. And in this map, we want to add the following kind of entries, right? So we want to set the cups key to be the number 46, the candles key to the value 121, and then the vases key or vases key to the value 15. Okay, so these are key value pairs, string to a number pairs. You can think of it like inventory or stock, maybe for a store or something like that. Okay. Then what we want to do is we want to use a for of loop. Okay, so this is a way to loop over an iterable, which a map is. And it also allows us the added functionality of being able to actually use destructuring in a simplistic way. So if you don't know for of loops very well, I have a video on that as well. You can also check on MDN on how that works. But effectively, the for of loop syntax, what we want to do, we want to loop through the store using kind of this syntax, const something of, and then in this case, the map store. And we want to use destructuring though inside of this for of loop construct. Okay, so kind of the hint is in this area right here, we want to actually use destructuring. And this is kind of that pattern binding matching destructuring that I hinted at in the video before this, where we went over the concepts. We want to destructure out the key and the value using the array style destructuring. Okay, so we saw how destructuring works with the array syntax with maps, sets, and strings. And we can use it inside of the for of loop construct to actually get that working. Then within the loop, I want you to print out the key and the value on the same line, separated by this little arrow symbol. So for example, we would get something like this printed out for the cups key and value. We get cups and a space and then the arrow and then another space and then 46. So most importantly, make sure your loops body, so inside the for of loops body, it only has one line of code. And that line of code is going to be the console log to actually log this out. And you can use a template string for this, or you can even just use a bunch of commas inside of a console log. Okay, so definitely a bit tricky. Give that a shot, and then we'll go through a possible solution together. All right, so to start, we want to create our store map. So I'm going to say const store is equal to a new map. And then we have to use the map API to actually set the values, which is why it's a bit different from objects, among other reasons. So I'm going to say store.set, and then we set the key to the value. So in this case, I want to set cups to be 46. Just going to duplicate this lines a few times. I'm going to set candles to be 121. I'm going to set vases to be 15. Okay, so that sets up our map for us, right? And just to really show you what's in there, let me just do this really quick. So I'll just log out to this map, and I'm going to run node exercise 2. And you can see that we kind of have 3 values in here. So that's the size of the map. And we have our cups 46, candles 121, and vases of 15. Okay, so I'll just get rid of that log just for brevity here. Now we want to use a for of loop to loop through the store. Okay, so what we normally would do, and I just want to show you the kind of syntax first before you use destructuring, and then after. So we'll say const, for example, entry of our store. And I want you to take a look at what happens if I console log out that entry. So if I just kind of use this just as is, right? What we saw is that we actually get back an array of a key and a value, right? So when we use a for of loop with a map, we actually split the key and the value up into index 0 and index 1, specifically for the for of loop iteration. Okay, so if you think about this, if I was to ask you, how would you destructure this, right? Well, we know that here is that value that we're getting. So instead of entry, maybe I can actually just kind of put a destructuring syntax here, and I can say something like key and value, right? So I'm saying, please put cups into key, and then 46 into value, and then same candles into key, 121 to value, etc., right? So I'm just going to see if this works, and I'll kind of finish this off. All right, so look at that. So we actually get the keys and the values printed out, right? So that's pretty awesome. So this syntax is going to come up actually quite a lot. It's quite beautiful syntax, in my opinion. Very, very kind of concise, and very, in this case, I don't actually like the naming of my variable, so I'm going to change it in a second. But once you have good variable names, it just kind of makes sense. Like you read it and you're just like, wow, this feels almost like regular, just kind of English, right? Like a sentence. So that said, let me actually change these, right? So I'm going to say for each, so this is a store, so we're going to have items and then maybe quantities, right? So I'm going to say maybe the item and then the value instead is going to be the quantity. Now these are just variable names, right? But I highly encourage you to get in the habit of writing good variable names. We could do, some people do K and V, things like that, or X and Y, it's even worse. Don't get into the habit of doing that, because it gets really confusing to come back and look at your code to actually realize what those things are. The context really matters a lot. So if you put things like item and quantity, especially as your loops get bigger, or using this in a function or something like that, it becomes much easier to actually figure out what's going on. So this code doesn't actually change anything. This just changes kind of some naming. So what you can see is that I get the actually same result. Okay, so we just need to kind of make this format right here, cups and an arrow, right? So I'm actually gonna put this into a template string. I'm gonna get rid of this. I'm gonna put an arrow in between. I'm gonna surround this with a $, curly brackets, and this is string templating, $, curly brackets, where we're actually putting in the variable into that spot using the backticks syntax, as well as a $, and curly brackets surrounding the variables. So if I run this, now what we'll get is our actual answer, which is cups 46, candles 121, and vases of 15. Okay, so hopefully you can see that this is indeed one line of code inside of our for of loop. And now if you read this syntax, even just kind of looking at this loop, even if you didn't really know what store was, right, this makes quite a lot of sense, right? We have each item, and each item has its quantity. Okay, perfect. Now for our final exercise for this video. So quite a bit going on here. So let me kind of go through this slowly, and I'll give you a shot at it. So to start, we want to create a function called xyzCalc. And this is going to have a single parameter that's an object. It's going to expect that object that comes in as an argument later to have kind of this format right here. Okay, so this is kind of like an object with 3 properties, an x property, y, and a z property, and each of those has a value of a number associated to it. Okay, this function is going to effectively just do a mathematical calculation, okay, using x, y, and z. It's going to do 5 times x minus 2 times y minus z. Okay, this is very common in things like game development. Sometimes you see this in things like web development for calculating position on a screen. Obviously, this is a tricky kind of mathematical calculation to some degree. It's like in 3 dimensions, so you might not always see something like this. The web is usually 2-dimensional with just an x and a y, but just to get a hang of how we could kind of do some fun math in here. At least I think this is fun math. Hopefully it's not too scary for you. This is literally the formula that we need to use inside of our code. Okay, so what we want to do then is call this function using the following objects and make sure that we actually get the correct results, right? So this is just kind of a recap on functions. If you kind of need a refresher on that, I also have a video on how functions work and parameters and arguments and return values and all that kind of stuff. But effectively, if we call our xyzCalc value or function, sorry, with an argument of the objects that look like this. So there's 3 different objects here, x of 20, 2, and 7. We should get 9 or 89 in that case. X of 2, 1, and 20 for x, y, z respectively. We should get negative 12. 100, 100, and 100 for x, y, and z. We should get 200. Okay. So give that a shot, make sure it actually works as expected. Then once you know it works and the function works correctly, what I want you to do is I want you to see how you can use destructuring inside the parameter list for the function. So I said that this function has a single parameter that's an object, right? So you probably gave that object a name. So how would you actually kind of replace that with destructuring directly inside of the function declaration to pull out x, y, and z? Okay, knowing that you're going to be getting an object in place of that kind of argument. Okay, and this is kind of as opposed to normally how we would do this where we're pulling it out of the body. Okay, and then I want you to kind of redo steps 3 in this case, just to make sure it actually works correctly and gives you the same answer, so nothing changed. Then I want you to kind of answer, which of these methods do you prefer? The one before the destructuring or the one after, and why? And then which one do you feel is more clear? Maybe if you were to come back in this in the future and look at it, is it more clear kind of after destructuring or before? Or maybe for like a friend or a coworker or something, what do you think that they might prefer? All right, so I'll give you a chance to try that out. Definitely quite a few steps in here. If you do get stuck, don't worry. Just come back to the video and we'll go through it together. Okay, so let's start by doing step 1. So it's quite a lot of stuff here, so I'll hopefully try to fit this all on the screen. We're going to say const xyzCalc. This is going to be a function, just like that. And this function is going to take an object. Okay, So for now, I'm just gonna call this obj, which is a terrible name. Do not use generic names like this for your functions. I just wanna show you kind of how we'll kind of eventually change this to be something neater, because you can see it's very confusing at the start. All right, so that's kind of step one. Now for step two, the function is gonna return the following calculation using x, y, and z inside of the object. So there's a few ways we could do this, right? We want to say 5 times x minus 2 times y minus z. And we want to return this. But x, y, and z are inside of the object. So we could say obj.x, we could say obj.y, and then minus obj.z. Okay. Now hopefully you can see that this is kind of, I don't really like this, right? Now we probably would need more context for kind of how this object is actually set up and what the purposes is, but I'll just give you an example of something we could replace this with, right? I could just say something like chords, and this is short for coordinates, right? If you think of a XYZ plane, if you've done that in mathematics, this is probably a bit more clear and something you might see in things like game development, for example, or even on web. Okay, not necessary, but I think just a bit easier to read. We want the x coordinate, the y coordinate, and then the z coordinate. Okay, so hopefully this works. Let's test out our function. So I'm going to kind of grab these here, and I want to call this function. I'm going to say console.log. And I want to get rid of that. Let me just set this up really quick for myself. There we go. There we go. And then there we go. All right. So what I want to see is 89, -12, and 200. So what I'm doing is I'm calling the function with these objects. And you can imagine that this gets replaced with that object. So chords is going to be this object, and this object, and this object. We're pulling out the x value, y value, and z value, doing this mathematical calculation and returning that number. And then we're doing console log on that result, which gets returned back to us from within the xyz calc function. All right, so moment of truth. I hope I did this math correctly. We'll do node exercise 3, and it looks like I actually did. So we have 89 and -12 and then 200. Okay, fantastic. So our function is working correctly. We're good to go. So I'm actually just going to comment these out for just a second. And I want to kind of think of what we want to do with step 4. So now we want to actually destructure out the x, y, and z coordinates. Okay, so I'm going to copy this function here, comment it out as well, and I'm going to actually redo it down here just so that you can kind of see the difference. All right, so when this object right here, right, gets pumped into our XYZ function, technically that's an object, and we know that we can actually destructure objects, right? So what would happen if we know beforehand this is an object, and we also know that we can pull things out of an object using their keys, right? So we can say x, y, and then z, right? And this is going to match, it's going to pattern match or bind to the x, y, and z inside whatever gets passed to our xyz calc function. Okay. So once that happens, now we no longer have chords. We just have x, we just have y, and we just have z. Okay. Now we could also technically go further than this and actually give some of these default values as well if we really wanted to get fancy, right? For example, we could say z is like equal to 1. If it wasn't provided or it wasn't inside the object, we could give it some default. I'm not going to do that for now. I'm just going to keep it simple and just show you that we're going to pattern match x, y, and z and bind x, y, and z to 20, 2 and 7 respectively for this one. X, y, and z are then going to be 2, 1, and 20 for this one, then 100 for each of them for the final one. Okay. And now if I kind of console log these out using the exact same console logs, let's see if we get the same answer, right? So we want to see the same answer as here. And look at that, right? That's pretty amazing. So it works the exact same way, looks like a little bit of magic. And this is kind of just some nice syntax that's provided to us as a result of destructuring. Definitely not something that we couldn't have done before that operator in JavaScript or that concept in JavaScript before. And people used to do things like this all the time, and they still do sometimes, right? But now we have a new way to actually work with this. And it's really up to you which one you prefer. So to kind of answer these questions, right? Which do I personally prefer? I think that if it's a very like obvious or standard function, and I'm going to be using those variables a lot, for example, maybe inside of the actual function body, instead of just constantly typing like chords.x, chords.y, chords.whatever, I could actually just pull those out, and I will use this quite a lot, right? I say this all the time, but a lot of frameworks these days, they use this kind of throughout the framework all the time, and they're very kind of promoted patterns, right, to actually use. So I personally prefer the syntax most of the time, right? There might be some cases where it maybe is more clear to actually use something like this. Sometimes I struggle to think of what those are. I usually try to use the destructuring syntax in areas like this. Okay, which is more clear? Now that is a much more subjective question, and sometimes some teams might totally not want to use this at all for whatever reason, and they only want to use this method. Some people really swear by the old school method. Some people really swear by the new school method. I would still probably argue that in most cases the destructuring is a bit more clear, because inside of the actual function body, we can name these keys directly and we're pulling them out, because we're always going to need the keys inside of the object, unless the name of the object is giving us some maybe extra context as to what is actually happening in the function and the purpose of the function. Usually you don't really need it, and you can rely on the actual just names inside of that object to actually give you kind of that kind of intuition for what that object is doing, especially combined with the name of the function. Okay, so that is kind of the end of these exercises. I hope that that was a bit of a challenge and fun for you. If you liked these exercises, I'd love it if you could like the video and subscribe to the channel. I'd love to hear in the comments what you thought of these exercises. Do you personally use destructuring a lot? Which of these do you actually personally prefer? Which do you think is more clear, and why? It's always really fun to see kind of what different developers think and what different teams think when it comes to kind of methods like this. What we're going to do in the next video is go over kind of another shortcut that's been added to JavaScript. That's kind of the theme for these few videos, and which is called the ternary operator. And that's going to allow us to shorten our if-else statements in a very kind of concise way. So I'm really excited to get to that, because that also pops up everywhere and people have wonderful opinions about that one too, and we'll kind of go through a couple of them. So if that sounds exciting to you, I'll see you in that video.